Hello, my name is Eloise. Our friend Rafilwe is back with us again today.
Hello! So what do we have planned for today's lesson?
Well, so far in this series, we have worked with points, lines and shapes on the Cartesian plane. Today, we are going to put this knowledge to practice. So far, we have worked with formulae to find the distance between 2 points, the gradient of a line segment, and the midpoint of a line segment. By the end of this lesson, you should be able to use coordinate geometry to explore and identify the properties of different quadrilaterals.
Eloise, I've been wondering, other than in maths class, when will I ever get to use this maths again? I mean, I know that maths gets used all the time, but who's really doing this kind of maths?
Well, you might be surprised to find that you have already seen some examples of coordinate geometry in action.
I have?
Yes, you just aren't aware of it because it was behind the scenes. Coordinate geometry is used to fly a plane, track down a stolen car, and even to find where you are or where you are going. Although most people doing geometry today don't call it geometry.
But those things just use computers. They use programs that do what they want.
Exactly. But think further. Who made those programs?
I guess computer programmers.
Actually, you will find that many of those programmers are mathematicians. They create the programs that work out coordinates and transformations of points. And the programs that they design help people in other professions do their jobs with precision and accuracy. The computer programs we saw use a kind of grid system with coordinates to tell us where we are or where we are going.
I didn't think of that. That sounds just like coordinate geometry.
It is. Although we don't always see it, mathematics is happening all around us. And with computers and other advances in technology, it has become more important than ever.
You've just given me something to think about. I hope I get to use coordinate geometry someday in my job.
I hope so too, Rafilwe. And there is no better time than now to start practicing.
I want to be really brilliant at my job someday. So, what's first?
First, we need to discuss a few things about quadrilaterals to see how we can use coordinate geometry on them. I'm going to give you a quadrilateral, a four-sided shape. I want you to prove that it is a parallelogram using coordinate geometry.
This shape looks like a parallelogram to me, but I suppose you want more than looks like. Where do I start?
Why don't you start with what you know about parallelograms?
Let's see. I know that the opposite sides of parallelograms have to be parallel.
Good start. Now, how can we prove that the opposite sides WX and YZ are parallel?
I know. We can use gradients.
Great, Rafilwe. And you know how to find the gradient using this formula.
Yes, so the gradient of Wx is 0 minus 2 over 6 minus 1, which is equal to negative 2 over 5. The gradient of zy is negative 3, negative 1 over 5 minus 0. That's also negative 2 over 5.
So they have the same gradient, so that means that Wx is parallel to Yz. I've already worked out the gradients of Wz and Xy. Have a look. They both came to 3 over 1 or just 3. So WZ and XY are parallel and both pairs of opposite sides are parallel, and that means
that WXYZ is a parallelogram.
we could have used some of the other properties of a parallelogram. For example, we know that the opposite sides of a parallelogram are equal.
So you could find the lengths of the sides.
That's right. The distance formula will help you with this. We also know that the diagonals of a parallelogram bisect each other. We could show this by finding the midpoint of each diagonal. So we can use distance, gradient, or the midpoint to prove that a shape is a parallelogram.
That's so cool. Let's try another shape.
Okay, here's another one. If P, Q, R, and S are the vertices of a quadrilateral, show that PQRS is a rhombus.
Isn't a rhombus just a special kind of parallelogram? So it has all the properties of a parallelogram.
You are absolutely right. And if you show that the opposite sides are parallel or that they are equal, all you've proved is that it is a parallelogram. What makes it different from a parallelogram? Do you remember something about its diagonals?
They bisect each other? But that was true about a parallelogram as well.
Yes, but the rhombus has one more special property. The diagonals bisect at 90 degrees. If you can prove that a shape has this property, then you have shown that the shape is a rhombus. Let's start with a sketch. We have plotted all the points we were given and joined them. So the diagonals are PR and QS. Let's start by showing that they bisect each other.
Okay, if the midpoint of each diagonal is at exactly the same point, that would show that they cut each other in half.
Exactly. So the midpoint of PR will have an x-coordinate of 1 plus 4 divided by 2 and a y-coordinate of 5 plus 4 divided by 2. That's going to be 2.5, 4.5. And if we do the same for QS, we find the midpoint of QS is also 2.5, 4.5.
So the midpoints of both lines are the same point. Since they're the same point, we know that the diagonals bisect each other. But we haven't shown that they're 90 degrees to each other yet.
Well, let's think. If lines are perpendicular, we know that the product of their gradients is -1. If we find the gradients of PR and QS and multiply them together, we will see whether they are perpendicular or not. The gradient is 4 minus 5 divided by 4 minus 1. So for PR, that will be -1/3. Then for QS, the gradient is 3 minus 6 divided by 2 minus 3. So that's 3. -1/3 times 3 is equal to -1. And that means?
That means that the diagonals are perpendicular to one another.
So we have shown that this shape's diagonals bisect at 90 degrees. It is therefore a rhombus. Well done! Today we have seen how we can use coordinate geometry and the different formulae that we know as tools. They have helped us to prove the special properties of the parallelogram and the rhombus. We can do the same for the rectangle, the square, and other quadrilaterals. But I will leave that to you. Here's your next task. Given A, B, C, and D, show that ABCD is a parallelogram, but it is not a rectangle. So, Rafilwe, I guess you really know your way around the Cartesian plane by now.
Yes, I'm pretty comfortable with it. And I recorded all the good stuff in my book. Thanks for the lesson. It's been fun.
I've enjoyed it too. Thanks for helping us out. Well, I think it's time we said goodbye.